What's up, guys? So katong previous video, we talked about the overview of our course, and then we now go directly to the discussion proper of our course. So starting with Chapter 1. So Chapter 1 is all about a review on vector analysis. I guess you've already undertaken the vector analysis as part of the topics in your previous courses. I guess you've taken up this in your mathematical physics 1 or 2, and also in your general physics course, wherein the very fundamental or basic knowledge that you all need to master in order for you to understand physics concepts is all about vectors. So, karon mag-review sa ito because vectors are very important in physics, especially in electromagnetism. We'll be talking a lot about it. So ako sa nipagamihan. Okay. So this is our course, Electromagnetism. And let's go now to this is the course outline. So for the midterm, for the coverage of midterm, it will just include the following topics: vector analysis, differential calculus, integral calculus, and I think up to integral calculus. And then for the final term, we will be learning the following: curvilinear coordinates, electrostatics, and then special techniques. Now, this is electromagnetism 1, the first half of the electromagnetism, the whole electromagnetism. For the electromagnetism 2, that will be on second sem, you will be learning much more on magnetostatics. Okay. So what's inside in this vector analysis, or the subtopics of this vector analysis? We have vector operations. So kabalo ko familiar na gid mo ani. We'll just have a run through on this. Review lang gid siya. So vector operations, how to do vector algebra in component form. So easy na kayo sa inyo. Then we also have position, displacements, and separation vectors. These are the very fundamental concepts, the core concepts that we need to master or understand for you to be able to comprehend or do some mathematical calculations, tapos ma-imagine niyo unsa na siya all about if you know all of these things. Okay? So in this course, we'll be talking entirely on two things. As the name of our course suggests, it's electromagnetism. So it's derived from two separate words: electricity, and then magnetism. So these are two separate entities. They thought that these are two separate entities until some known scientists before, the likes of especially Maxwell, he discovered that these two seemingly separate entities, electricity and magnetism, so to speak, they are actually one and the same. Right? So nakadungog naman ang story, di ba nga? That's the unification of the two seemingly separate entities. So electricity is born from the changing magnetic field, right? And magnetic field is produced by the movement of electrons, so they have electricity. So related na sila it's like two sides of the same coin, if you like. So these two phenomena are described in terms of the fields and electric charges and currents, so the term electric field and magnetic field arise. So we have the following subtopics: vector operations, vector algebra in component form, position and displacement, and separation vectors. Okay? So this whole chapter, to be more generous sa inyong case, I'll be giving you 2 weeks time frame for you to finish this chapter of vector analysis. So that 2 weeks time, that's equivalent to 4 meetings. So by the end of this chapter, there is an assigned problem set that needs to be submitted. So just watch out or keep posted of the deadline. So you may submit the required problem set for this particular chapter on or before the set deadline. So the learning outcomes for this particular topic of this course, you should be able to define scalar and vector and explain the similarities between them. Analyze and solve problems involving calculations on vector algebra, both in geometric and algebraic form. Also, you should be able to understand the concepts of positions, displacements, and separation vectors vividly. So dapat klaro siya. And before we can proceed to the next topic, make sure that there would be no issues or misunderstandings or difficulties ng mga mga concepts nga wala nga sa kani nga topic is nag-struggle pa dai mo. So dapat ma-settle na siya before we can proceed to the next topic. So as I've said at the outset of this course, do not hesitate to ask me directly if you don't understand or there's a part of this topic that you find it difficult or lisod mong sabot. Okay? Ayaw mo kauaw. Okay. So in electromagnetism, we always talk about electric field and magnetic field, but what exactly a field is? So sama ng field, according to physics, field is the most fundamental entity. Fundamentals, yeah. So when you say fundamental, it cannot be broken into further more particles or details. Like for example, if you have an atom is not a fundamental entity. Why? Because an atom can still be broken down into subatomic particles such as electrons. We have neutrons, then under neutrons, yeah, and then we have protons also. Now these electrons, neutrons, and protons are still not considered as a fundamental entity because these can be broken down still. Experiments have shown this, that it can be broken down into smaller particle, and that's what we call quarks now. So these neutrons, protons, electrons are composed of quarks, right? Now these quarks are considered to be fundamental, I guess, but not in a sense. Actually, there's a catch, because quarks, electrons, protons are produced from a field actually. So before the universe was born, there was actually field. So walay particle, so nag-exist is field. It's like a sea of, let's say, a body of water, a sea, and a sea is considered a field. Now, what creates the notion of a particle? Now, if you drop something on the water, let's say you disturb the water, then what will happen is it will create ripples, right? Ripples of waves. Now, that ripples of waves is what we call particle. Now, kinsa may mas nauna, of course, ang sea, and that's what we call the field. So the field existed before, and then particle created because of a disturbance or excitation of energy in more technical term in physics. Okay. So field basically is just a function, so a function that describes a certain physical quantity at all points in space. So field, just like temperature field. So let's say in my unit, in my apartment, in your house, even in your house, it's actually filled with a temperature field. Now, anywhere you go in your house, there's a particular number of temperature. So that's a field. So it's defined at all points in space. Maybe in your kitchen, it may be quite hotter compared to your compared in your sala, right? So there's a field. So lahi ang value sa temperature at all points in space, in yung kwartos, in yung salas, in yung CR. So that's a field. So more importantly, in physics, there are two types of fields. Now, what I mentioned kanina, temperature field, that's what we call a scalar. So scalar siya because wala may mention of direction. So it doesn't matter kung unsay direction sa temperature, right? It's just the value at that particular point that matters. So the scalar. And we also have vector fields. So scalar fields specify only a quantity in space, as I've said kaganina, temperature field. That is, it only gives a single number at all points in space. So masayo na siya i-imagine, right? So examples of scalar are the following. As atong temperature ganina, we have also pressure. So for each point in space in a certain room, naa siya defined nga value of pressure. Then we also have Newtonian gravity and many more. On the other hand, vector fields both specify a quantity and direction at all points in space. So magmatter na ang direction. Example, wind velocity. Right? So sa wind velocity, magmatter ang unsa ka kusgon, the strength of the wind, and also where it is going. Asa man siya? Direction, north, east, or west, or south. So that's vector fields. So importante ang direction and also the magnitude or the value. And also we have ocean currents as an example of a vector field. Now for this course, vector fields will be represented as a boldface type. Now vector field general na siya. We're not actually only talking about the wind, the ocean, and so on. We'll generalize it as a vector field, okay? And we will be representing it as a boldface type. So any vector field that is represented as a boldface, while italic indicates a scalar type of quantity. So encounter nato ni siya kaning mga boldface and italic as we go on, as we go along with our course. Also, we will adopt the right-hand Cartesian coordinate system. So let's take a look at figure 1.1. So this is the right-hand Cartesian coordinate. So sama na siya. So we have, this is x, and then this is the y, and then the z. Ang uban pud nga mga say references similar gyapon ani. It could be nga ang dili kani ang iyahang orientation, pwede na adri ang x instead na z ni siya, na adri ang x, okay? And then this will be the y, and then the z. So all you have to do para yung malibog is i-follow lang yung ang right hand rule, always the right hand, okay? So this is the like the physics gangster nga sign, right, or symbol sa hand. So you have the x, the y, and then the z. So siya corner. Now in vectors we can also do a lot of things. So we can do manipulations on it, we can do operations, we can add, we can subtract, we can multiply, we can also divide, okay? So any vector quantity contains both magnitude and direction. So for example, imagine you are walking 4 kilometers due north. So as you can see in figure 1.2, so you are walking 4 kilometers due north. So as seen in this, as depicted in this figure, and then you make another walk so straight gyud diretso ba pag abot mo sa 4 kilometer nga distance, right away you turn right, or you turn east, and then walk 3 kilometers distance, okay? So as shown in this figure. So by then you have traveled a total of 7 kilometers, right? 7, diba? Because you have 4 due north plus 3 due east, so 7 ang siya, okay? But in actuality you are only 5 kilometers away from the starting point. How is that possible? The hypotenuse, right? Dili man kani ang i-measure, right? So this is your distance, pero ang displacement is kani the shortest path. So ang kaning ang iyahang longest angle, diba? This is Pythagorean theorem. So this is actually 5 kilometers. So how did we calculate 5 kilometers? So two ways. Pwede niyo siya i-measure yun, di ba? Pwede man i-measure, magdagan ka diha. So 5 kilometers na siya. Or the easiest way, because we know math, we are smart, so we can just do the Pythagorean theorem. So itong Pythagorean theorem na formula, let me test my saan niya akong di ko ka-draw, sorry. So triangle na siya, diba? We have c square equals a square plus b square. So you just do the math. You take c, the hypotenuse, a is 4, b is 3. So you take the square and you take the square root of everything, then you get 5. I think masabtanan ninyo. It's basic. So adding these quantities does not add in an ordinary way because quantities such as these displacements have both magnitude and direction. So it is essential to take both into account when you combine them. So pag combine mo sa vector quantity, duha mo consider, and aside from the magnitude, you also have the direction. And the same direction will add up and opposing direction will be subtracted. So as mentioned in the introduction, we will denote vector quantities with a boldface type and ordinary or italic type for scalars. So we will then introduce the 4 basic vector operations, so the addition and the 3 kinds of multiplications. So let's take a look at the addition. So addition, let's say you have 2 vectors, A and B. So how do you add these 2 vectors? So simple naman ang rule. If you take a look at it, let's say you want to take the sum of 2 vectors in geometrically, so figure siya. So ma-imagine siya ba? So you have the idea is very simple. You just place the tail of B at the end of A, right? So if you have A plus B, so isang nimo from the tail of A to the arrow to the tip of B. So that's the sum of A plus B. So inana siya simple. So how about this? Or this is B plus A. So the same raman is here. So B plus A. So the tail of B up to the tip of A. So we have B plus A. So that's one property of a vector because the addition of a 2 vectors or any vectors is commutative. So it doesn't matter if A comes first or B comes first. So the order doesn't matter. So commutative siya. It's like 1 plus 1 equals 3. The same one is 2 plus 1. So 1 plus 1 is equivalent to 2 plus 1. Okay. Then we also have associative. So associative is, it doesn't matter kung asa yung unahon og add. Pwede A plus B. So we have A plus B plus C. Pwede ang unahon nimong A plus B or unahon nimong ang B plus C. It's the same. Doesn't matter. Then we also have subtracting vectors. Actually, mag-subtract ang vector is just the same as mag-add ka, but you take the opposite sign sa isa. The same po na siya sa number, right? If you have 1 minus 2, that's actually equivalent to 1 plus negative 2. So at the end of the day, it's just addition, right? Addition siya. Pero gi-change nimo, gi-flip nimo ang sign sa isa. The same thing also is true even when we are dealing with vectors. We have A minus B. So that's equivalent to just by saying A plus the negative B, negative version of this vector B. So how do we represent that figure in figure? So we have this figure here. So we have A and then the negative B. Okay. So if we add mo siya, they have the masayo siya i-imagine, right? Because if we do vector addition, the formula is very simple. From the tail of A up to the tip of B. So kana. Okay? So if you have questions, you can just comment down below. Okay? Or you can contact me through my cell phone number, or you can message me sa Facebook, or you can just arrange a one-on-one consultation via Zoom if you like, or Google Meet. Then next property is how do we multiply a vector? So first, we can multiply a vector through a scalar quantity. So if we multiply a vector by a positive scalar A, it scales the vector according to A. So kung unsa ang imong gi-multiply, mao pud ang resulting vector. Let's say akong vector is this So this, say, ano siya kataas is of this length ang vector. If I multiply it with 2, so mo double po na siya, right? But if I multiply it with 4, so twice po ana ang iyang kadakon. So what I'm saying is, if this is your vector length, if you multiply it with some scalar, let's say 2, 3, 4, so multiplication siya is a magnification. So mo scale po ang imong vector. So however, if A is negative, the same gihapon yung result actually, but mo flip ang direction. So instead na naadin mo ana siya. So take note also of the length of the vector, depende kung pila imong gi-multiply. Kung duha, so times 2 po ang length, kung upat times 4. And there's one property of vector that we need to consider, is that scalar multiplication is distributive. So if you have two vectors a plus b, and then you multiply the whole thing by a scalar quantity a, now by virtue of distributive property, each ani is matagaan siya og mamultiplyan siya og a, right? Ang a ma-multiplyan og ang vector a ma-multiplyan og small a, ang vector b ma-multiplyan pud og small a. So this is what I'm talking about. So you have vector a multiplied by 2 scalar 2, so times 2 po ang iyang length. Then we have vector dot product. So review na niya, so you can actually skip this if feel ninyo nga kamo na kuha ng sir, okay na, sige, okay na po na siya. But for the purpose of this course, let me just run through this topic, kay crucial kay ni siya. So vector dot product. So the dot product of two vectors is defined by this equation, given in equation 1.1. If you have vector A multiplied by vector B, it is just equivalent to A, B, or the magnitude of A and the magnitude of B times cosine theta. Diba? Mama na siya ato ang formula good sa vector product. But in reality, if you can picture out kung unsa gid ang dot product, is actually a projection. So if you have A times vector B, it's actually A projection onto B. So meaning, unsay shadow nga i-cast sa A onto B. Di ba naka-mention ako na before? I forgot unsa itong klase na to. Basta naka-mention ako ni about dot product. It's just a projection. I think sa computational physics 2. Right? So, dot product is just a projection. Right? Kung unsay ang shadow nga i-make. And it's given by this equation. Now, if the two vectors are perpendicular with each other, so wala shadow nga ma-form, right? Okay, let's say if you have this vector A and this is vector B, and notice that they are perpendicular to each other, and if you do multiplication via vector product, na unsa may shadow nga i-make ani over ani, right? Wala. Ang shadow niya ani is, let's say the light is coming from the zenith, so nasa top. So ang shadow niya ani is wala, 0, right? So if you have a two vector perpendicular to each other, the dot product is always 0. Okay. If you have parallel nga gaana gid siya, so ang shadow niya is tanan siya is just 1, right? So one important property of dot product is it's commutative. So it doesn't matter kung unsa ang order, whether mag-una ang A or mag-una ang B. So A dot B is equal to B dot A. Okay? And at the same time, it's also distributive. So if you have these two vectors here, the sum of two vectors B plus C, and then you take a dot product of it with sa A, so ma-distribute ang dot product niya. So you have A dot B plus A dot C. So geometrically, the dot product A dot B, as I've said kanina, is just a projection of vector A onto vector B. So kanin siya. If you have A dot B, so unsa man ang shadow nga i-make sa A onto B, let's say ang light is coming from above. So ang shadow niya is na dire. So if mo drawing tama diha. So na diha. And that's actually equivalent to just by saying AB times cosine theta. So kani siya nga distance din that's AB cosine theta, right? Mama na siya. If you draw a line here, so triangle man na siya. So by virtue of SOHCAHTOA. So imo na siyang i-recall ang katong SOHCAHTOA. This is actually AB cosine theta. So in particular, for any vector A, if you have, as I said kanina, A dot A, this is actually equivalent to A square. And if perpendicular siya, so it's 0. So walay shadow nga ma-make. So ang iyang vector with itself, dot product with itself is maximum. So ano siya, A square. So let's have an example. So let's take a look at this. Let's see B A minus B. So asa mo ni ang kani siya nga figure 1.6. So kani. So ang C daw it's A minus B, and calculate the dot product of C with itself. Okay. Let's take a look. So C dot C, okay? Oh, nasayop ni siya. Kulang ni siya og sorry. Naani siya ay close parenthesis here and a dot product, okay? Sorry about that. So if you do this, so ana, you multiply C by itself, where C is equal to A minus B. So, sa may buhatan ana, di ba? Foil method. So, you have A dot A. So, you have A dot A. And then you also have A dot B. And then, you have B dot A minus B dot A plus B dot B. Okay? Oh, sayop niya akong kuan din eh. So, you can actually follow, right, ang iyang progression, di ba? So, or simplifying this term here, this equation, you get this. So, I just leave this to you sa inyong balay. Inyo na siya isolve. Tapos makuha niyo siya. So, take a look at this equation. C square equals A square plus B square minus 2AB cosine theta. This is familiar, right? Because that is exactly the law of cosine. Kung mali ang cosine, kanang law of cosines man, nagabiton man ang law of cosine if dili siya mo follow sa katong right angle na triangle, diba? So, mo ni siya. Dili, okay. Dili di ay gikan ang formula sa law of cosine. It's just a dot product of C by itself. So we now go to the another type of vector product. We have cross product. Kanina it's dot, karon it's cross. So the cross product of two vectors is defined by equation 1.5. So instead of sine kaganina sa dot product, AB cosine man to. For the cross product, it is now sine. But there is now a direction because cross product is actually a vector. Ang yang output is a vector quantity. Unlike dot product, if you have a dot product of two vectors, the result is always scalar. It's just a number. But for a cross product, the output is another vector. So another vector siya with some direction depending on giunsa siya pag cross product ang duha ka vector. So where n hat, this is n hat, is just a unit vector of length 1. So, unit vector na siya pointing into unsa nga direction. It could be pointing in the x direction, y, or z direction. More on this later as we take an example. So, take note that there are two directions perpendicular to the plane, and that is in and out. So, this can be resolved by utilizing the right-hand rule. So, take a look at A. So, if you do A cross B, asa man ang direction niya? Right? Ang direction niya, if you have, okay. So, you can do this also at home. Siguro, magbaliktad siguro sa kuha, kay mirror man ang ako ang perspective sa inyo, ha. So, if you have A cross B, so, ang A nimo is, imo siyang iana sa imong hand, kani. Tapos, i-sweep off nimo padulong sa B. Notice nga, ang direction na niya is, actually, if makatubang mo laptop, it's towards your laptop. Right? So, ang direction niya. But if you have B cross A, baliktad na po. Ang direction niya is away from your laptop screen. So, nagets niyo? By just using the right-hand rule. So, let your fingers point in the direction of the first vector. Then, you curl along toward the second. And then, the thumb kung kani siya the thumb will indicate the direction of the resultant or the resulting vector. So if you have A cross B, it points into the page or into your laptop screen. If you have B cross A, it's now opposite. It points out of the page or points out of your laptop screen. Easy, right? So note that A cross B is itself a vector, as I've said. So actually, ang kaning cross product is just kung mo siyang i-imagine geometrically, if you have A cross B, it's actually the area of this parallelogram. Right? So it's just the area. So area na siya sa parallelogram with direction pointing where? Depende. If you have A cross B, it points into the page. But if you have B cross A, it's just the area of this whole thing. So if you have B cross A, the area of this whole thing with the direction outside, pointing out of the page. Now, unlike the dot product, which is commutative ang iyang product, for the vector product, it's not commutative anymore. So B cross A is not the same as A cross B. So you have to put a negative sign. So ma-flip siya, di ba? Kaganina. Kita mo na ito sa example. If you have A cross B, mo niyang direction. But if B cross A paana, B cross A is paana siya, A cross B is paana. So baliktad ang direction. So it's not commutative. So opposite ang direction. So mo nang giyon ganina. Geometrically, the cross product of any two vectors is just the area of the parallelogram generated by the two vectors. Interesting, eh? Area ang iyang i-produce tapos with direction. So in fact, if two vectors are parallel, so wala kay area nga ma-make, wala parallelogram, so it's zero, which is opposite siya sa dot product, di ba? Maximum no noon if dot product, but for this case, zero siya if you have cross product of a two vectors by itself, kasi parallel siya. Now, kaganina what we did a addition and multiplication of vectors geometrically, so kato mga arrow like, but that could be not helpful actually when you go to advanced physics, because not all vectors kay ma-imagine siya, ma-drawing ba, let's say, medyo vague maguna siya if mo asa lang ka sa drawing. To be more exact, we have to quantify vectors kung unsa gyud ang iyang sum, iyang product, asa ang direction. Then the vector algebra in component form comes now into the picture. So mas accurate ni siya, mas exact gyud siya. So in practice and in most cases, it is a lot easier if we set up Cartesian coordinates x, y, z and work with the vector components. In our case, for our course, let x hat, y hat, and z hat be the unit vectors. Unsa ni mga unit vectors? Kung siya ang katong asa ang direction sa x, asa ang direction sa y, asa ang direction sa z. So as I've said, kani siyang x, y, z, parallel na siya sa x, y, and z axis respectively, as shown in figure 1.8a. Tara. So this is x-axis. So asa ang direction niya sa unit vector? It's along the x. So we have x hat. Same thing is true with the y hat and the z hat. So let's take a look at figure 1.8b. So an arbitrary vector can be expanded in terms of these basis vectors. So let's take a look at this vector A. So kanang vector A in Cartesian coordinates, kani vector A ni siya. So tanawa ako ang arrow sa laptop. So this is vector A. So na siya 3 components in 3 dimensions man ta. So you have A sub x. Now what is this A sub x? This is the magnitude unsa kadako, unsa kataas ang imong vector at going sa x direction. We have na po siya y component, y hat, and then the z component, A sub z, z hat. So a vector is always defined in terms of its components. So tulo ka buok, we have x component, y component, z component. Other vectors can only be defined by just using 2 components because nara siya sa surface. Or maybe some other vectors kay isa ra gyud ang iyang component because Dahil siya sa line, di siya area. So vectors may be added and subtracted as we can see in equation 1.8. So you have vectors A, B. If you take the sum or maybe the difference of between these two, you have this. So for the vector A, ang component niya is AX, AY, AZ. Also with B. If you take the sum, notice nga ang imuhang gisam lang is katong pariha o component, right? Di man pwede nga ang karabaw i-add nimo sa baka. So only karabaw, apple. So muna siya ang case diri. Like similar same component. So katong x component sa A and the x component of B must be added together. Also with the y components of the two vectors A and B, and also the z component of A and B. And also for the vector multiplication, what if we multiply the vector with a scalar? So naatay 3 components gihapon, and each component is multiplied by this scalar A. Okay? How about if we do that product? So similar gihapon siya sa addition. You multiply similar term or same term. So i-multiply nimo ang x, so say AX and BX only. Then we have AY and BY only, and then AZ and then BZ. And you add these 3, it will just give you one single number. So because the dot product of two vector is just a scalar quantity, so scalar number na siya. So in calculating the dot product, you multiply same components and then you add. O na siya. So if you have A dot A, vector product of A by itself, so you have AX square, AY square, or AZ square. So if we have this vector product, this is actually just the magnitude. So say magnitude sa A. So take the square root of that, so you have AX square plus AY square plus AZ square. So mura ni siya o 3D nga form sa Pythagorean theorem, right? So you have kani siya. So similarly, you can also do cross product. So ang cross product medyo ano lang siya, medyo difficult or complicated. Dili siya na nakasayo ng ihang rule compared to that product. I think naka-encounter na mo ani mag-multiply og matrix, di ba? So you have vector A cross product with vector B. So again, we expand the vector A in terms of its components, as well as the vector B in terms of its components. You have AX plus AY plus AZ. Same thing is true with the vector B. Now, when you do vector product, this is what happens. It becomes as shown in equation 1.12. Now, yung sum na siya pag-abot. So, naatay gigamit nga expression. So, we have, ang tawag kanina mo sa una is basket method. So, we have two vectors. We just use the basket method. So, it's actually easy. Nani na siya. So, for the x component, kani x component, imo na siyang i-crush out. So, imo na siyang how do I sige lang pohon mag-upgrade ra ko ani og pro kaysa pro man good is maka-annotate ko aning PDF pa maka-drawing ko. May karon wala pa man siya na-upgrade. May budget. So kani. So you crush out this one, so yung siyang tabunan lang ni siya, right? For the x component kani, tabunan lang na siya. And then what you do is you multiply the diagonal term. AY times BZ, so naa siya din eh, right? AY times BZ minus ang kaning diagonal pod AZ times BY. Kana. That's for the x component. And then minus, so minus na siya always ang sa cross product. Tabunan na pod mo ang y, tapos you multiply the diagonal sa x and sa z. So you have AX times BZ, times AZ times BX. Okay, sa yun ang pattern, di ba? And then for the kulang na siya. Nana siya z dapat diri. So z hat. For the z hat, tabunan na siya. You have AX times BY, as you can see here, minus AY times BX. Ano? Right? That's how you do cross product. So let's take a look at this example. Now find the angle between the face diagonals of a cube. No, tanawa. This is the face diagonal of a cube. Oh, the face diagonal of a cube. Find the angle between the face diagonals of a cube. So kani siya. Kaning unsay angle ani? Kani siyang theta. So you have A, vector A, and then you have vector B. So na may solution diri, which is easy to follow. So we'll use a cube of side 1 and place it. It's shown in the figure with one corner at the origin. Okay. The face diagonals A and B are kani. Yun sa man siya. Take a look at vector A. Sa vector A, naa siya length nga 1, di ba? Yung x component is 1. However, for the y component, wala siya y component. Kaya naa naman diri ang y. Ang iyang component nila is x and the z. So we have x, 1, z kay 1, 0 ang y. So this is now your vector. This is your vector component sa imong A. How about for the B? So ang B is naa lang siya y and z, wala siya x. So kana. So 0 ang iyang x. So kanang x 0 jud na. Then 0 gina ang value. Okay. Then we have y naa siya 1 and then z naa po siya 1. Okay. So in component form, if you do a dot product on that, so i-dot product nimo siya. Later on, may bawaan nimo nganong kailangan siya i-dot product because what we are looking for is the angle between the two diagonal. Right? Diba mag-dot product maka sa diagonal is as mag-dot product ka sa two vectors actually is dot product of AB is actually AB cosine theta. So makuha na nimo ang theta dayon. Aha. So ana sine na jud siya. So take a look at let's do the dot product. So 1 times 0, so like terms i-multiply. So 1 times 0, 0 times 1, and then 1 times 1. So that will give you just a value of 1. The rest is 0. Okay? So on the other hand, in abstract form, so naatay A dot B, marang yung i-mention ganina. AB cosine theta. Then A, where did we get? How do we get A? A is actually a magnitude of A. So how do we do that? Just multiply vector A by itself. So if you multiply vector A by itself, sa ating formula, di ba, square root naman to siya. Square root of ax square plus ay square plus az square. So you have 1 square plus 0 square plus 1 square. That's actually 2, right? Or square root of 2. That's why we have square root of 2 as the magnitude of A. Maupod sa B. Ang magnitude niya is square root of 2. Multiplied by cosine theta. Okay? Now, square root of 2 times square root of 2, that will give you 2. So, that's 2 cosine theta. Now, unsay value aning A dot B? A dot B is just 1. Nakuha ito ganina. So, this is just 1. Therefore, cosine theta is just 1/2. Tanawa, 1/2. So, ano siya? Cosine theta is just 1/2. Now, to get theta, you just have to get the inverse. So, inverse of this is just 60 degrees. So, okay, nakuha na to. That's it. The angle between these two vectors, the face diagonal of a cube, is just 60 degrees. Na lang. Of course, you can get the answer more easily by drawing in a diagonal across the top of the cube, completing the equilateral triangle. But in cases where the geometry is not so simple, more complicated na geometry, nga di na madag drawing, ma-imagine ba? So this device of comparing the abstract and component form of the dot product can be a very efficient means of finding angles. We just have to stick with this kaning calculation because you can never go wrong with this calculation. Now down to the last subtopic for this chapter, we have the position, displacement, and vector. So kani siya gamit di kani siya sa electromagnetism. Always ito mag-refer ani say electric field, magnetic field, electric potential. Mo na siya ayang representation na position vector, displacement, and separation vectors. So we can describe the location of a point in 3 dimensions by listing its Cartesian coordinates x, y, z. So the vector from the origin to that point is called the position vector. Take a look at figure 1.10. So this is the position vector, right? Yan eh. From the origin to the to the point, kani siya nga point. So that's r, this is what we call r vector, kani siya nga vector. Where r hat is just the unit vector along with the direction of the vector r. And ang magnitude niya, kaning r, is just katong multiply the vector by itself, kani siya. That product by itself. So you have x squared plus y squared plus z squared, and then you take the square root of the whole thing. And ano siya? We also have, ano siya? We have this position vector from the origin to the field point. Ano siya? But we also have a source point. So, ang source sa katong, let's say, it could be electric field, or maybe electron siya din, positive charge, or maybe negative charge. So, from the origin to that source point, that's what we call R prime. So, ato na siyang i-remember per me. Imagine ba? Because when we will be having more examples later on, solving electric field at a particular point, so, it's very important to remember what are these vectors involved. So, mga involved ani is kaning vector r from the origin to the field point. We also have r prime from the origin to the source point, and then we also have the vector, which is the once again tawag na separation vector. So, the vector it's a vector between the source point and the field point. Ito siyang tawagon og script r, script t, or script ang iyang notation. So muna ang magnitude and iyang what we call this, the unit vector is given by this. So ang r hat is just equal to the vector r over the magnitude. Right? Muna siya ang formula, r equals r times r hat. So if you want to get the unit vector, is just you do the cross multiplication, ana. Excuse me. And then the infinitesimal displacement vector from xyz to x plus dx and so on, it's given by this. So it's gamay siya nga change sa imuhang displacement vector. Okay? So in this course, we will frequently encounter problems involving 2 points. A typical source point is what I've said kanina, where an electric charge is located, and a field point, this is the field point, this is the source point, at which you are calculating the electric field or magnetic field for that matter. So we can use this notation here, the script R, to denote the difference between the field point and the source point. And its magnitude is given by this. So, and a unit vector in the direction of that vector script R is given by this, equation 1.20. And in Cartesian coordinates, so we have the following. Okay. So this is the vector. This is the magnitude of the script R, and then the unit vector of the script R. So from this moment on, you will begin to appreciate the advantage of script R. So most of the time, magamit tayo script R. Okay. That is the distance between the source point and the vector between the source point and the field point. So you can try this, this exercise. So find the separation vector script R from the source point 287. Tuning 287 katuning yang sa Cartesian coordinate ba, 2 sa x, 8 sa y, 7 sa z. To the field point 468. So you can mo siya i-drawing sa siya at first para mas masabtan niyo ang problem. And then you determine its magnitude script R, and then construct the unit vector. So just use equations 1.21 to 1.23. And then if makuha na niyo siya, you try to submit it to me. So you can work it out by hand. Use a pen and paper. And then after that, i-picturean ninyo siya, and then you send it to me. So you actually given 2 weeks man for this particular topic. So taas review master gid ninyo. So deadline ani actually di man ni siya kuan kanang it's just a quick exercise. You take a picture, a snapshot of this and you send it to me in any platform. Pwede na sa Google Classroom po i-send ninyo. And then this is your problem set for this particular topic. So ang deadline ani is 2 weeks. So let's say nagsugod ihatag na ko na siya September 7. So deadline ani is a week. So this is 1 week man siya. So ang second week niya is kani. So tagaan ta mo ay na lang ang deadline for every problem set is a Friday. So pwede ra Friday before midnight sa 19. So dapat na email na siya. So submit na siya sa Google Classroom. Accept akong deadline ana mo remind man na ang Google Classroom na deadline. So this is your first problem set. Side na siya 5 numbers lang. So pwede ano siya mahuman ganig 3 days. Muna 3 days, 2 weeks ni siya nga allotment. So dakan pa kayo mag-time study sa inyong open subject or mag-advanced study mo. Okay? So naa siya evaluation for this is for katong mag-modular ba. But for our case mo di man ta mag-modular. So let's just leave it as is lang. Okay, that's all for this topic. And again, as I've said at the outset of my discussion, if you have questions, clarifications, that maybe magkailangan ka mag-set of one-on-one consultation with me, you can just directly contact me, message me sa Facebook, or i-text ko sa akong number. I will be glad, more than willing to assist you and help you sa inyong problem maybe or issue nga mo arise. Okay? That's it, and see you next time. Bye. Stay safe.